Welcome grade 10s to the Edge. We are going to start our series on waves, sound, and light. So the intention is to just give you an introduction as well as a summary to waves, sound, and light. One of the things that you have to know is what is the definition of a wave. But before we get into that, we need to know that there are two types of waves that we're going to look at. One of those is called a transverse wave, and the second one is a longitudinal wave. There are also other kinds of waves that we're going to look at later on. I'm just going to use a different pen. These are sound waves and electromagnetic waves, EM waves. But we're going to look at this at a later stage in our series. So we need to know how to define what a wave is, or yes alone know what is a wave to begin with, right? And one of the ways that we can understand this is by first defining a pulse. This is, I would say, the simplest form of a wave, right? So what a pulse is, first of all, is just simply a single disturbance along a medium. So just write it down. Single disturbance along a medium, and this medium could be anything. It could be air, it could be water. So basically this is where your pulse or your wave will move or will pass through. So in this case we can just write this as the rest position, which can also just indicate our medium. So this is what a pulse is. And one of the things that we have to note is, how do we describe this pulse, right? So a pulse has an amplitude, which you can write as R or A, whatever it is. And basically this amplitude is simply the distance from the rest position to the maximum point of our pulse. But it will be also the same definition. Instead of pulse for waves, it will be just a wave, but we'll look at that later on. Right, so this is the simplest form of what a wave is. So obviously a wave will be many of these pulses in succession, like following each other, but this is where we start. So the reason why we start with defining what a pulse is, it's going to also help us get into a very important concept known as superposition, right? Let me just move to a different slide. I'm just going to write it here, superposition. There are two types of superposition. There is constructive interference and destructive interference. So basically what superposition is just when two pulses are moving towards each other with a certain amplitude along the same medium. The amplitudes can either add up to create a bigger pulse, or they can subtract from each other, create a smaller pulse, or if they're the same, they can just cancel each other out. So no pulse or a smaller pulse. So if we can just say this is A1 and this one is A2. So let's say A1 is bigger than A2, so you can subtract A2 from A1, which will give us A3, and this one would be less than A1 plus A2. So they can, in this case, these are moving. This is the crest, this is the trough. And so these waves are moving towards each other, but they're definitely not on the same position, as you can see here. But in this case, if we can just do that for constructive interference, this is A1 and this is A2. We add them together. Say A1 is equals to A2, or it could be that A1 is greater than A2, whatever it may be. Those things will add up. Those amplitudes will add up to A3. So this is a very important concept that you guys need to learn. It also happens for waves as well, but it's simpler to understand them when we are using just a pulse. So I think we can move on to waves now. We've dealt with a pulse. So we said that a pulse is just the simplest form of a wave. So what will be a wave? A wave, one of the definitions is a succession of pulses. Or a wave can also be described as a disturbance along the medium. So this is going to help us to also define what we know as a transverse wave. And in the next video, we will describe or define what a transverse wave is.